In this class, we're going to use a definition for work as the transfer of energy into or out of a system. We take this car, for example. If we draw a free body diagram for this car, the only forces acting on it are mg, the weight, and the normal force of the surface on the car. No forces are acting to increase the energy of the system. If I get behind the car and push the car, I'm now adding a push in one direction, increasing the velocity of the car, giving it kinetic energy. We can calculate the amount of energy transferred from me to the car with the simple equation work equals force times distance. Okay. Since my force is in the same direction as the velocity is to the right, the force is to the right, we call this positive work. This is positive work because energy is being added to the system. All of our discussions about work will be from the point of view of the system. The crate, the person, the car, the rock, whatever object we're talking about that you drew a free body diagram for, that is the point of view we're talking about. If I let go of the box and allow friction to act on the crate, so now the situation is normal force up, mg down, and I've stopped pushing and we're on a rough surface, so the only force acting on the crate is the force of friction, which is the opposite direction of the velocity. The velocity is still to the left. They're opposite directions. So we call this negative work, because energy is leaving the system through friction. And when friction happens, normally it leaves the system as heat. So we have a difference between positive and negative work. Okay. We call positive work often work done on the system, and we call negative work work done by the system. Okay, so if you ever see work done by the system in a problem, they're talking about negative work. If they're talking about work done on the system, we're adding energy, and it'll be positive work. It should also be noted that the amount of work done by the normal force is 0 joules. No work was done by the normal force. 0 joules were done by gravity, because they are not lined up with the motion at all. They're perpendicular to the motion. So they do absolutely no work. Same thing here. 0 joules and 0 joules. Joules are a unit of energy, if you recall from our discussion of kinetic energy and potential energy. The only other thing you need to know is that since work equals force times distance, force is in newtons, distance is in meters. Sometimes they will show you Newton meters on the exam. You need to know that Newton meters are the equivalent to joules. They are both units of energy.